Welcome to Papa Junk Shop. Got a new digital DC power supply to check out. It's a little bigger than my my other one. This one is 0 to 30 volts and 20 amps, I do believe. So we got a couple of lugs. And we've got a operator's manual. Tells the different model numbers and the specifications. The shows all the controls, what they do, front and rear. Description of each function. Features, method of operation, constant voltage, constant current characteristics, system settings, specific setting items and parameters meanings are shown in the following table. And looks like there's a fuse in the AC input socket. So we're going to refer to the instructions if we can't figure something out. Let's see. Didn't I see a... Okay, there's some caution stuff here. Okay, that's just your usual stuff. What do we got here? Be careful. In actual constant voltage operation, the output current increases to the set current value when the load resistance decreases. If the power supply will automatically switch to CC mode. Yeah, we'll figure all that out. Looks like it's packaged pretty well. And an AC cord. And we got leads. Really heavy leads. 20 amp power supply comes with 30 amp leads. Now that's nice, because this other little power supply, the leads are nice and flexible and everything, but boy, there isn't much to them. And you know, when you got it maxed out at 6 amps, there's some voltage loss in those leads. So I've been kind of watching for some heavier, nice flexible wire so I can upgrade them. But let's check these out. Yeah, they're not silicone, but they're not bad. I mean, you know, it's cool in here. It's only probably 50 degrees Fahrenheit. Looks like we got, I believe those are soldered on ends. Looks like it right there. The same here, you can see the, here I can see the solder, can you? Yeah, looks pretty decent. Okay, here we go. It's a Wanptek DC Power Supply, model KPS3020D, 0 to 30 volts at 20 amps. That must be overcurrent protection switch, and this would turn the output on and off. Indicators to tell you whether it's in constant voltage or constant current. Looks like we got volts, amps, and watts. Got some nice screwed on instead of just stuck on with some glue feet. That's nice. All metal case. The front's plastic, of course. Ventilation's on the side. Pretty good sized fan in the back. The fuse is located under this little cover. And it takes a standard cord. Of course, this is a 120 volt model here in the United States. Well, 115. And these would be the output terminals. I'm guessing they're M6. So, let me get the cord unwrapped and the leads on her. We'll plug her in and see what she looks like when she's lit up. Now, before I actually hook it up, let's see how long the power cord and the test leads are. So, we're looking at 5-foot cord, power cord. And that's what, 152 millimeters about. Let's see what we got here. These are about 50 inches or 127 millimeters. Okay, get her hooked up now. Okay, got the test leads on, and there are 2 washers on those posts, so you can put one on each side of the ring terminal. So let's power her up. Now we got a nice beep. Okay, so they must have it set on max when they ship it. 31 volts, 21 amps. Okay, this is the voltage control. Okay, and I think if you push it, okay, and you can make a coarser adjustment. That's really coarse. Push it again. Okay, so you can do each digit, so you can really fine tune it. And I'm guessing the same thing with the yep. Alright, and then we got watts down here. Pretty nice. Alright, let me get something to hook up to her and see how she works. Okay, before I turn it on, I did look at the manual just a little bit, and it actually is translated pretty nice. Says the stability and ripple coefficient of the power supply are very good, with a variety of protection circuits such as short circuit protection, over voltage protection, over current protection, and over temperature protection. So, which I expected. So let's fire this bugger up. Okay, now I got a little resistive heating thing here that I made for something like years ago, and I don't even remember what for, but it's a low voltage thing, like 12 and 24 volts, so, and it puts pretty good load on, so that's what we're gonna try here. So I have to push this button to get it to output. Okay, so we're 11 amps and 9 volts, 109 watts. So let's try, let's limit the current to 4 amps. So if we limit the current to 4.8 amps, the voltage only needs to be 4.34. So okay, so that's saying it's over current from what we have it set for. So apparently I have to disengage that. Okay, so let's open this up all the way. Turn it on. See if we can get it up to the 20 amps. And this is an encoder, so there's no stop on it. Okay, there's our over our 20 amps. Let's see. Go to 21, and you can see these elements are lighting up pretty good at 20 volts and 426 watts. And no fan yet, I don't believe. No. We'll let it run there full bore for a little bit. See how long it takes that fan to come on. See how loud it is too. So what happens if we do? It says over current. Nope, nope, doesn't do that. Oh, jeez. So I'm going to have to look in the book and see just, that's not what I expected, I guess. So let me kind of time it here and see how long it takes the fan to come on. I'll be back and kind of keep track of time, let you know. While we're waiting for the fan to come on, let's take a look and see what the output waveform looks like. Now let's see. See what the voltage on this meter says compared to that. 19.96, 20.32 over there, but we've got some voltage loss in the leads, I'm sure. Let's see, just for the fun of it. Yeah, I got 0.12 volts loss in, I would say, probably each lead. Yep. And the fan has come on. It's either really quiet or it's variable speed. We'll see here in a minute. Anyways, let's take a look at this. What is it, this one? Yeah. Okay, this is full load. Panel there, and I'm getting out of range. Now, I haven't used this thing enough. Let me figure that out and I'll be back. Okay. That's with no load. That's with full load. You can see some, when I'm unhooking it, some where it's sparking, so. Looks like it's got a pretty good clean waveform. Get my leads out of there so I don't melt them. Alright, and the fan shut off. And I think the fan blows in because I can feel air coming out the sides. So, boy, seems pretty nice so far. There, the fan just come back on. I don't know if you guys can hear it or not. It's not very noisy. So let's back this off a little bit. Okay, and I'm going to see if I can figure out how this works. Well, this resistance heater thing wasn't a good choice to play with that because, you know, it's almost like a short circuit. But what the book says is when the OCP function is enabled, the power supply will cut off output immediately after entering the constant current state. After 5 seconds, the power supply will automatically restart the output if it's still in the constant current state. Repeat the above process to prevent the output current from overcurrent when the electrical appliance has a short circuit. Large damage to the electrical appliance. Alright, so I've got just a car light bulb on there now, and I've got the amperage set for 2 amps, and I've got the voltage turned down. I don't know if you guys can see that. It's just barely, it was just barely glowing. Alright, here we go. We're going to turn the voltage up. When that gets over 2, I'm thinking that's going to come on. This bulb usually around 12 volts is 2 amps. There's 2. Yep. Okay, to clear it, I'll have to do that. And if I turn it back on, it's probably going to go right back into it. Yep. Okay, so if I turn this voltage down a little bit, now it's cold, so let's, so when it's cold it will draw more, so that's probably, no, boy, she just goes right into it. Well, it does work. I'm probably just not using a good choice, but overall I think I'm really going to like this bugger. I mean, I like my other one, but it only goes to 6 amps, but it does go to 60 volts. This one only goes to 30. It would be nice to have one that went to 62, and you know, one like this with a higher amperage, and they do make them. And but this really isn't, I guess what you call a bargain power supply. It's a good quality supply, I believe. So I think it's around $200 for this, but I'm pretty sure that it's pretty well protected and pretty accurate, I do believe. So that's a quick look at the new power supply. You'll probably see it being used here in the shop, so hopefully it's going to be beneficial to somebody. And if you enjoyed it, give me a thumbs up, and if you haven't subscribed and like this kind of stuff, even though I'm not very good at it, but I can get your curiosity up. You know, give me a thumbs up and subscribe. We'll see you next time. I'm sorry, I didn't hear you guys yelling that you wanted to see the insides, because I kind of forgot myself. Alright. Got some pretty impressive looking toroidal coils here. Nice deep fins. Backed right up to the fan. And got some good sized caps there. 820 microfarad, 200 volt. And over on this side they are 2200 microfarad, 35 volt. That must be the current shunt. And let's see, It looks like maybe some MOVs on the input side. Okay, there's adjustment there for the overcurrent protection. And we have a separate circuit board for the display and controls. And all the cables are glued in place. Everything's labeled nicely. Nice heavy wires here. Now I can only see one component on the bottom of the circuit board. I don't know you guys, there is a resistor down there on the bottom. And there's a couple of wires attached on the bottom, and they are for the power switch. So overall the build quality looks really nice. And in the book it did say the fan was thermally controlled, so that, but I can't say for sure because, you know, I got my other fan running on my hybrid inverter over there, so, but it sounded like it come on slow and then sped up, but I could be wrong, so don't hold me to that. But everything looks good on the inside too, so nice power supply. See you next time. Thanks for watching.